we are on the home stretch here. This should be hopefully our last video key entry. We are on number 19. We are looking at aluminum crystallizing into a face-centered cubic cell, and we need to calculate the packing efficiency. Now, we actually, I did a whole video on this, so I'm just going to kind of go through this really quickly, and you can, feel free to watch that other video if it's still not clear. This is the face of our cubic cell. Each side is A. All right, since it's a face-centered cubic cell, this hypotenuse that's cutting through the face is 4R. If we were to draw our triangle here, draw the same length here, this is what we'd have. Each side, each leg being A, this is 4R. This is a 45-degree angle. The cosine of 45 degrees is equal to the square root of 2 over 2, which is equal to the adjacent over the hypotenuse, which is equal, in this case, to A over 4R. Excuse me. All right, so A, then, we've put A in terms of R. A is equal to 2R square root of 2. And if you recall from that other video, we need to put A in terms of R. So therefore, the volume of this cube would equal 2R square root of 2 cubed. Alright, so you get 1 point for this, 1 point for this. Alright, now that we found the volume of the cube, we need to, we can just go ahead and rewrite this real quick actually. R2 square root of 2 cubed. Okay, so now we found the volume of the cube, we need to find the volume of the atoms inside the cube, because remember, packing efficiency is volume of the atoms over volume of the cube times 100%. So we've got 4 atoms that are present in a face-centered cubic cell. Each atom we're going to treat as a sphere. The volume of a sphere is 4/3 pi r cubed. So we're going to take 4 times 4/3 pi r cubed, which equals 16/3 pi r cubed. Good. Get a point for this. And then finally, you get a point for calculating the packing efficiency. We take the volume of the atoms, 16/3 pi r cubed, over the volume of the cube itself, 2 square root of 2 cubed, r cubed. These guys cancel out, multiply this by 100%, and you get 74%. If this was confusing, I really encourage you to go back and watch the other video I uploaded, which is a lot slower. Alright, number 20. Alright, the atomic radius of aluminum is 1.43 angstroms, and this was the typo of the exam. This should be 1.43 times 10 to the negative 8 centimeters. I thought I was doing you a favor there. Maybe I made it more confusing. Anyway, 1.43 times 10 to the negative 8 centimeters. What is the density of the aluminum metal from the previous question? Alright, well, if you remember, density is equal to mass over volume. So if I find the volume of this specific cube, and I find the mass of aluminum that's present in the specific cube, I can calculate the density. Alright, let's go ahead and calculate, let's work on the volume piece first. Alright, so I can find, now I've got A in terms of R from this previous problem, so I should be able to find the dimensions of the cube. A is equal to 2R square root of 2, so I can take 2 times R, 1.43 times 10 to the negative 8th centimeters, times square root of 2. Alright, I can then find my volume of the cube. That's just going to be that value cubed, square root of 2, cube that. Great. Alright, so I get basically a point for doing this, and then I found my volume. Great. Here, now I need to find my mass. Mass is equal to 4 atoms times 26.98 grams of aluminum over 6.02 times 10 to the 23rd atoms. All right, now what I've just did might seem a little bit confusing. Essentially what I've done is I've kind of cut out the per mole step, okay? So I've said I want to convert atoms to moles, all right? In 1 mole, there's 6.02 times 10 to the 23rd atoms, okay? So I've got atoms to moles, and then there's 26.98 grams per mole of aluminum. Okay, so this is just sort of a shortcut here. All right, but anyway, found the mass. Great. So to find density, I take the mass, 4 times 26.98 divided by 6.02 times 10 to the 23rd. Let's call atoms here. Atoms. Okay, times the volume that I calculated, 2 times 1.43 times 10 to the negative 8th centimeters, square root of 2, cubed. All right, so what am I, this is grams, what am I ending up with? Grams per centimeters cubed. Dimensional analysis looks like it works out. I should get 2.71 grams per centimeters cubed. Sweet. All right, last page here. Number 21. Proteins are biopolymers composed of amino acid monomers. So we've got this chain of amino acids right here, and we're asked what category of polymer is this? This is a condensation polymer. All right, now we're asked to draw the monomers. This actually goes back to one of the homework questions that you had, where you had something that looked very similar to this, and you were asked to kind of rehydrate it, essentially, to redistribute the H2O that came off of that condensation polymer across that bond. All right. Now there's a couple different ways that you could draw this. All right, let's start with leucine here. All right, so we've got CH, and we've got NH3 plus CH2, CH, CH3, CH3. There's that side chain there. All right. C, double bonded to O, and then we've got this bond right here. All right, we need to redistribute an H2O across this bond. If you remember from the homework and from class, we put an OH here and an H with that nitrogen. Okay, OH. All right. Now, something that you might notice here. You might be saying, wait a minute, you're telling me that I need to write this as NH2, but this one over here is NH3. And I'm supposed to write this as OH, but this guy over here is O-. What gives? Here's the thing about amino acids that you would not know necessarily. Amino acids can actually change their charge states depending on the pH of the solution that they're in. So I accepted if you had it written in this form, or if you had it written C single bond to O-. Either one was fine with me. Same thing with the other monomers here that we're drawing. Okay, so let's draw now alanine here. Here's alanine. We've got our central carbon, CH. Whoop, I'm going to draw it a little upside down from what's on the paper, but that's okay. Alanine. All right, here, NH2. That's that extra hydrogen that's redistributed from the water, right? So a hydrogen from here plus that OH would make H2O, condensation polymer. Okay? And then C, which way? I'm trying to be consistent here, but that's all right. C double bonded to O, and then again, OH or O-. So this could be or NH3 plus, that's fine, or O-. Either one is okay, as long as you're consistent. All right, and then finally there's glutamate here. So there's our central carbon, CO, O-. I'm just going to draw the skeleton here because the side chain doesn't really factor in. NH2, again, this could be NH3 plus, that's fine. So you got 1 point here. You got 2 points if you got, the monomers correct. If you got all 3 monomers correct, I think I gave you an extra point. I don't know that anybody did, but I think that some people got at least one of them right, which was enough to get credit. So cool. All right, and again, it's really kind of from the homework. If you understood deeply that homework problem, this I think would have been a doable question. If you are concerned about it, I would recommend going back and looking at the picture and the problem that you worked in Chapter 12 on polymers, and it kind of breaks it down in a similar kind of way. All right, for number 22, we're asked to determine coordination number of aluminum for all of the following compounds. All right, now remember, if we're trying to find a cation coordination number, all right, it is going to be equal then to the anion coordination number times the anion number from the formula. Okay, so this would be, in this case, 3 over the cation number from the formula. Okay, so in this case, cation Cn is equal to 2, that's our anion coordination number, times whatever the number is associated with the anion in the formula, which is 3, divided by 1, the number associated with aluminum, to give us 6. All right, for this one, cation Cn is equal to anion coordination number 6 times whatever's going on with the anion in the formula, 3 divided by 2 to give us 9. Last one, cation Cn is equal to, where are we, 4 coordinate times 1 divided by 1 to give us 4. All right, and we're done with the Chemistry 102 video key.